Okay, so we're starting on page 12 of the notes, which is the gravity homework that you were supposed to do last night. Right off the bat, question 1 had a vocab word in it that is important for this chapter that we didn't talk about, that I kind of forgot all about. So it says the best evidence that erosion has taken place would be provided by. So first thing, since somebody mentioned that we might need to define the word erosion, on the top of page 12, what is erosion?
The movement of rocks.
Movement of broken rocks. Guys, what's another word for movement? Transportation. Okay, hey, I'm kind of in the middle of teaching. Can you just stop talking? So I added that. So it's the movement or transportation of broken pieces of rocks. So that right there is actually one of the words. What if I ever use the word transported material? At the bottom, we're going to define this. Transported material. What do you think transported material is? So it's something, whether it's broken pieces of rocks or soil or anything, it is sediments that have been moved from their place of origin by erosion. So a transported material, which I don't think you would have had a problem with that vocab word. Because transported material, they might call it transported sediments or transported soil. It's just soil or sediments or whatever that has been transported from one place to another. The word that I think you might not know that was used in question 1 is residual. And it is in question 1. It's called residual soil in question 1. But I am just going to stick with material, residual material. And that again could be soil or sediments or rocks. Residual. What does residual sound like? Like resident. That's exactly the first word that I always compare it to. So a resident is a person who's living there, not moving. Another word that I like to refer it to is residue. You guys know what residue is? Something left over. That's the perfect way. I like to tell you what residue is by talking about Kraft macaroni and cheese. Ever eat a bowl of Kraft macaroni and cheese? The yellow kind specifically. Only kind of macaroni and cheese my kids will eat. Well, they do like the Annie's too, but they will not eat homemade. But let's talk about the yellow ones for real. Weird, you're weird. So yellow or orangish Kraft macaroni and cheese. You eat a big bowl of it. You eat every noodle that you could find. Is your bowl empty?
No.
What's left in the bowl?
The orange.
The orange cheese. So unless you're licking out that bowl, which no judgment. So unless you're licking out the bowl completely, it leaves behind an orange layer of cheese. That is residue. It is cheese residue that is left behind in the bowl. So just like Sarah said, residue is something that's left behind after everything else has been removed. So after all the noodles have been removed, the cheese is left behind. So let's put that into talk about residual soil or residual sediments or material. So talking about earth science and erosion, what does residual mean? Residual soil, residual material. Material that's been left over or left behind. So in this case, it is going to be soil or material.
What's up, everyone's?
Soil or material which is left behind after an agent of erosion moves everything else. Oops, sorry about that. Soil or material which is left behind after an agent of erosion moves everything else. So if there's residual material, what has that material not done? It has not been transported. So if you find residual soil or residual sediments sitting on the ground, that means they have not been moved. So now we can go back to question number 1 on page 12. Everybody done with these notes? Can I move it? Okay, question number 1 says the best evidence that erosion has taken place would be provided by, and answer number 1 says deep residual soil observed on a hillside. Would that tell that erosion has happened if there's residual soil there? No, because Carter, what does residual mean? Hasn't moved. So is that good evidence that erosion has taken place if there's something that has not moved?
I think so.
No. Okay, so if there's something that hasn't moved, residual means it hasn't moved. It's not good evidence that erosion has happened. So out of these 3 that are left, which one is the result of erosion? Remember, there are 5 agents of erosion. Waves, water, wind, gravity, and glaciers. Yes, answer 2. Sediments observed at the bottom of a cliff. So if you have a whole bunch of broken rocks sitting on the bottom of a cliff, that means they were moved there by gravity. Now these other 2, tilted and faulted rocks, those are evidence of plate tectonics. Those aren't evidence of erosion. So remember, erosion is only by those 5 agents: water, wind, waves, glaciers, and gravity, not plate tectonics. How about this next one then? Question 2. Which erosional force acts alone to produce avalanches and landslides?
1.
Yeah, I think that one was pretty easy. Gravity. Which movement of Earth's material is gravity not the main force? Hey, by the way, I never talked about this. What is the force of gravity? Pulling something down towards the center of the Earth, downhill. Which one of these is something not moving down? 4. Moisture evaporating from the ocean. In that case, the moisture is going up from the ocean into the clouds. So that's not gravity. That's the opposite of gravity. All right, diagram below shows a sequence of events leading to the deposition of a landslide debris.
Gravity.
What is the primary force that caused the landslide? Yes, gravity. Glacial movement is caused primarily by gravity. And the primary force responsible for the flow of water in a stream is gravity. All right, I'll let you guys make the decision. Should we go back to page 9 or move on to page 13? What do you want to do first? 13? So we're going to talk about wind erosion next. So this first one, yes, these are long questions. Yes, you should have read every word. It's the number 1 rule of earth science. So you should have started up at the top and read that it shows the movement of wind-driven sand particles that strike a partially exposed basalt cobble located on the surface of a windy desert. So here's the basalt cobble. Here is the ground that it's sitting on. A little bit of it's buried. Here's the wind-driven sand that's hitting this rock every day. The wind is coming from this direction. We want to know what this cobble will look like after many years. Can you give me a show of fingers so I can see which one you picked? which one of these, 1, 2, 3, or 4, is the cobble? Look at me, don't look at everybody else. Most of you have the correct answer. It is answer 2.
Let's go.
But my question is, how do we know that? Kat, what about question 2 or answer 2 is the right answer? What about that cobble? The side of number 2, specifically the side the wind is hitting, is more worn down. What's wrong with 4? Huh? In this case, it looks like something weird happened in the back side. This part is not, that's not up there. So in this case, it almost looks like it grew. I think what they were trying to do is trick you with the shape of a sand dune there. So a rock isn't going to get bigger ever because of erosion. It will always get smaller. They didn't trick you? Good.
Yeah, they didn't trick me.
Perfect. Now question 3, there's a lot to read there. And you really should have read all of the words, including looking at the picture and reading the picture. So the cross section represents a part of Texas where weakly cemented sandstone is exposed at the surface. The mineral cement holding the sandstone grains together is calcite. Area X is a circle depression of loose sand that has been partially removed by prevailing winds. Sand dunes have developed downwind from the depression X. So I look at the picture. Here's that depression filled with the mixture of the loose sand grains. Here's where a sand dune is going to develop. Now here it says on the diagram in the area of a sand dune development provided to the right, draw a sketch showing the general side view of a sand dune formed by wind blowing in the direction indicated. Your sketch should clearly show any variation in the slope of the sides of the sand dune. How does a sand dune look? We drew this on page 8.
It's like
A gentle side and a steep side of a hill. Which side's gentle? The side with the wind. So it says the wind is coming from this way. So we have a gentle side on the wind side and a steep side on the other side. So I walked around and I looked, I think, at most of yours. My main thing I want you to know is you have to emphasize this. See how much more gentle this side is than this side on my picture. Don't make me get out a protractor and measure your angles to see if it really is a smaller angle than this side. Just emphasize it. So don't make it so it's almost like that. Like I can't really tell there. Don't make me guess. Don't make me measure. Really gentle, really steep. And the gentle side is always on the wind side. No. Anybody not sure if their sand dune's good enough?
No, my sand dunes are definitely.
All right, so I guess now we got to go back to page 9.
Oh,
This is the way you guys wanted to go.
that's one.
Oh, you just wanted to skip it.
Yeah,
Got it.
that's right.
Yeah, that was definitely not what I meant. We can go a little faster for some of them at least. So we are on to page 9. Result of glaciation and has a positive effect on the economy. Now, more than one of these answers might be caused by glaciers. They might not all be positive. Or they might, more than one might be positive, but they're not all caused by glaciers. So which one do you guys think it is? Thinking it's 3? Many deposits of gravel were formed.
Is that right, Michelle?
If you answered number 3. Let's just talk about, did we talk about natural gas and oil formed from a glacier at all?
No.
So do you think that just means I forgot? No, that is not how oil and natural gas got here. What about this one? Number of usable water reservoirs were reduced. What's wrong with that? There's multiple things wrong.
Said it was reduced, so it's not quite positive effect.
Okay, 1, that would be a negative effect. Absolutely. If they were reduced, that would be a big negative. And then what'd you say, Sarah? Glaciers made more water reservoirs instead of taking them away. Absolutely not the right answer. And Yes, glaciers could have removed fertile soil. They also could have left it behind, but this is definitely not a positive. If they removed fertile soil, that would be a negative. All right, we found those large boulders in Syracuse. What statement explains the presence of these large boulders? Remember, this is my favorite thing. Which one is it, guys? Show me your fingers. What'd you put? You all did your homework. Tell me what you picked. Okay, you didn't do your homework. Nice job, guys. Yes, those boulders were transported to the area by ice. Number 3, which rock material is found transported to its present location by a glacier? Glaciers, we did talk about glaciers. What do they always move? What can a glacier move? Anything. Which one of these? So will the glacier have rounded sand grains? They could, but is that what a glacier is known for? No. Which one are glaciers known for? Nope. Again, not rounded. Rounded. Yeah, rounded are going to be from running water. It is for glaciers are known for their unsorted sediments.
Yeah, Kaden.
All right, again, you got a picture here, and without the description, the picture is kind of weird looking. The diagram represents a profile of a mountain glacier in the northern United States. So here we have a mountain. Here's the glacier on top of it. It's moving downhill. How does a glacier move downhill? 3. Gravity pulls the glacier downhill. Now, speaking of going downhill, your velocity. Do you guys know what the word velocity means?
Yeah,
Speed, how fast. What is going to make change how fast a glacier goes down a hill? How steep the hill is. Just like if you were sledding. If you have a steep hill, you're gonna go faster. A gentle hill, you're gonna go slower. So I see some of you crossing off your answers. What one did you pick as a wrong answer?
I picked 4.
That's what I was thinking. Size of sediment transported by the glacier. Do you know why you picked that one?
Because, the thing transported, transported by the glacier, I figured it moved the glacier moved. Oh, yeah, the bigger the rock goes, the slower.
Yeah, and that does make sense, but put me and my daughter on a sled. 2 different sleds. My daughter's this tall, 60 pounds. Who's making it to the bottom of that hill faster? Yeah. Okay, that's another way of looking at it. Okay. So the bigger the sediments, it's actually gonna change. So I see that actually does not help the answer. You were right. That didn't help that explanation whatsoever. It is the movement of the ice is going to be controlled by the slope. So that was a tricky one. I don't like that one. I don't know if a glacier moves slower if it has more, or faster if it has more stuff in it. I feel like it would change, but I don't think it's. There we go. There we go. They're talking about the size of the sediment, and they're not if there's a lot of it or not. So it could be carrying a bunch of little stuff or a bunch of small stuff, big stuff. It doesn't matter. It's going to go the same speed. All right. Sorry. Number 6. If the climate warms up, the glacier melts away. What is the region going to look like? Yeah, U-shaped valleys. Remember, that will be there. How about this one? Over a period of years, the glacier gains more snow mass than it loses. What will most likely result? So if we're gaining more than it's losing, will the size decrease or increase?
4.
Okay, so you're telling me increase. So I like to get rid of wrong answers first. And then if it's getting bigger, will it advance or retreat? Yeah, it'll move forward if it's getting bigger, advanced. How about this one? I really want you to get this right. So if you didn't do this one and think about it, I want you to think right now. Which one of these looks like sediment that was transported by a glacier? Show of fingers. Now that you're thinking instead of just circling, not that that would have happened to anybody. What answer? Okay, show me any fingers. What answer you picked then? Do it. Do it. Participate, you guys, show me. Kate, I know you weren't here, but we already talked about it like 3 times. Give me an answer. Which one of these looks like it was transported by a glacier? Why did you pick 4?
There is hand.
Okay, so what about 4 is different than everything else? What do you notice about these pieces of rock here? Different sizes. Glaciers, huh?
They're sorted.
They're not sorted.
Unsorted.
Oh, they're unsorted. Okay, let's go with unsorted. Unsorted. Now, this one has a mixture of sizes too,
Sorted.
but it still is sorted. It's in nice, organized layers here. Glaciers don't organize anything. Glaciers just go through and drop off a pile of junk.
A good way to remember it is if everyone's like an ice cream place or Dairy Queen, and you got, we call it Blizzard, M&M's and Nerds, and they make scoops. That's kind of, it's unsorted. You don't get a Blizzard or whatever, it's got layers, nice, number 1. So
Yeah.
4 is kind of good. There are no Oreo cookie Blizzard, ice cream.
Mr. D, do you mix Oreos and Nerds together? Ew.
It is. Good. It is.
Wow, I just learned something new about you. I love Nerds and I love Oreos. I would never mix them together.
Don't knock it too
Too sweet, like,
No.
you're making my cheeks pucker thinking of eating
Ooh,
that.
a Sonic slushie, the blue.
With
slushie
Nerds.
with Nerds.
Yeah, that I'll buy, but not ice cream
No,
and
never-
Oreos.
Do that again.
Don't go together, Mr. D. I have a major problem with your order. I really like the analogy, all mixed up and messy.
Oreo
But-
and Nerds together eat, now look at them. Oh,
You want to eat that?
got it. Touch your mouth.
All right, back to glaciers. Blizzard, I like the analogy because blizzards and glaciers, they kind of even have a connection, talking about how everything's mixed up. Just a terrible choice, so that's all. Number 9, this one is really important you read these directions, because otherwise you're just seeing a bunch of arrows and junk on a map.
4.
But those arrows, as it tells you over here, the arrows on the map show a location and orientation of glacial striations on the surface of a bedrock. Dark shading shows the locations of large moraines, which they did define there as glacial deposits. But you know what? We never defined striations. I told you you didn't really need to, but I want to now.
4.
At the top of this page, page 11, I want to define the word striation. I just gotta spell it right. Striation. What is a striation?
Something silly.
Not quite silly. So glacier causes striation. But what is a striation? Nah? Okay, this is a good thing we're writing it down. This is when I use the sponge to wash a car analogy.
Oh, it picks it up.
Well, that it picks it up, and what does the glacier picks them up? It leaves marks, scratches. Striations are nothing more than scratches. Scratches on the bedrock caused by a glacier. So note to self, next year we need to write all these definitions.
Waste and.
Scratches on bedrock caused by glaciers. Yeah,
I'm not gonna note that.
yeah.
I would just leave it on the board unless you.
So they're telling you that these arrows are showing you the orientation of striations. So they're saying all these arrows are showing you they start there and go there, start there and go there. All the arrows are showing which way they're going. So question 9 says, the striations indicate the movement of the glacial ice was towards the. Are they, every question starts with, so northeast, northeast, southeast, northwest, which way? Are they going north at all?
Oh,
So-
I'll say the answer.
Any answer that has anything about north in it are wrong. Double check, are some of them going southeast and some going southwest? Yes.
I didn't have to read any of that, I just put down what started here.
Well, that was good luck then.
So
Now this next part, um,
I skipped it.
yeah, it is skippable because we're really gonna learn this next chapter. I will tell you, I'll show you how to do it. So first of all, where in New York is this map, is a map of? What about this map tells you exactly where it is?
New Jersey,
So you see New Jersey,
Long Island.
Long Island, that's the kicker right there. So that's one thing that they might do to you. They might give you an ugly map that matches up with your map in your reference table, but you gotta figure out where it is. So this does tell you here's Long Island and the Long Island Sound. So there's Long Island, there's the Long Island Sound. Now, when we used this map back in September and October, I told you to ignore the background stuff. We just use this for latitude and longitude. Starting today, we're done ignoring that. So now what you have to do is look at the key. So the key does tell us geological periods and eras in New York. That's just time periods. So instead of saying 2023, when we're talking about large times from a long time ago, they use names like some of these might, here's Jurassic. Does that sound familiar to anyone? Jurassic.
Park.
Yep, so that's when the dinosaurs were around. This is chapter 6, by the way. We'll get into this. Yeah, we're gonna go to Jurassic Park in chapter 6. But these are just talking about time periods. And they match up with the symbol. So you can see here in Long Island, the symbol is like, there's like dashes and polka dots all in the same area. That matches up right here, which is from the Cretaceous and Pleistocene. And what do you know? Answer 2 is the Pleistocene. All the other ones don't match up with Long Island.
Oh, I guess I got that right.
For the record, guys, this will not be on the chapter 5 test. This is a chapter 6 question.
That's crazy.
Now moving on though, observations of which feature are most useful in determining the thickness of an ice sheet. So this one, the ice sheet's gone. It's not outside right now. So yeah, keep looking, it's not there. But there's evidence that a glacier, some evidence that glaciers were around. Now, let's look at this. Grooves on a bedrock near the top of Bear Mountain. How did the grooves get there? How did the grooves get there? From a glacier. What did the glacier do to make a groove? It slid down the mountain. And what did it do to make a groove? It picked up rocks. It's basically scratches. If that glacier, if you take that dirty sponge and you have a really big rock in it, or you put a lot of pressure on that sponge while you're washing it, it's gonna make an even bigger scratch than just washing your car normally. The grooves, the bigger the grooves, what's gonna make a bigger groove? Larger rock or larger glacier in the first place.
That's what I was thinking.
Now glacial soils in southern Connecticut, will that tell you how thick it is? How thick the glacier itself was? No, that's only gonna show you what was left behind. Glacier boulders at the bottom of Long Island Sound. Again, that's not gonna tell you how thick the glacier is, it's just gonna show you what it was carrying. And again, scratches on loose rocks at the mouth of the Hudson. The loose rocks, that's not gonna be left over from the glacier still, the scratches. Well, the scratches were from a glacier, but the loose part, we want those grooved bedrocks. That's what's gonna tell you how big the glacier was on top of it. The bigger the grooves, the bigger the glacier. How about this one? How are striations made? We just talked about this. Reread all 4 answers, see which one. 2, rocks at the bottom of a glacier were dragged over the bedrock. Moraines. Now they did tell you right here what a moraine was. Moraine is a glacial deposit. So moraines are recognized as glacial deposits because they are composed of materials that are. When a glacier deposits anything, what do we know about those deposits? Yeah, you just did it. What are they? Glaciers deposit what? Yeah, I just made you do it a minute ago. Glaciers deposit what, guys? Mr. D and his blizzard example, messy, unsorted, disgusting flavors. But which one of these is gonna tell you messy then?
Oh, yeah.
Which one, many different size and layered? Are blizzards layered? The glaciers leave layers? Not layered, so we don't like any layered. Many different sizes and not layered. Messy. Layering something is kind of how my kids clean their rooms. They kind of organize the mess into new messes, if you ask me. Okay, sound familiar? Okay, that's still just like layering your mess. So unlayered and unsorted, many different sizes is gonna be from a glacier. And finally, because of glaciation, New York State presently have soils that are best described as. So because a glacier came through and eroded materials, will we have deep residual soil?
Yeah,
What does residual mean?
movement.
Not moved. So because a glacier came through, we're gonna have a lot of soils that haven't moved? No, glaciers move stuff. So along that same answers, because of glaciation, will we have a lot of areas unchanged by glaciers? No. Do glaciers have anything to do with rich gemstones? No. Could they have left us with thin and rocky soil?
Yeah.
Yes, they took away a lot of the soil and left behind some rocks for us. Yep, that is gonna be it for the rest of the period. You have a whopping 4 minutes and no homework tonight.
Let's go.
Let's go.
Yeah.